The function f of x is not defined when x equals 2. Why? What happens to the values of f of x when x is very close to 2? If we substitute x equals 2 into the function, we get the following. In the numerator or on the top, we get 0. And in the denominator, we get 0. The 0 in the numerator or on top is not a problem. However, the 0 at the bottom is a problem. So if we substitute a value, and when we substitute it, we get 0 in the denominator, we say that the function is not defined for that value. When discussing limits, we're not interested in what's happening at the exact value, but around that value. So although at 2 we are not defined, let's look at what happens close to 2. We will use a table of values to look at the behavior around 2. The point of interest is 2. Now let's find some values to the left of 2. A value close to 2 would be 1.9. Now we will select a value even closer to 2. Let's try 1.99. And now we choose a value even closer to 2. Let's try 1.999. Now let's find some values to the right of 2. First, let's try something like 2.1. Now let's try a value closer to 2, like 2.01. Now let's select a value even closer to 2, like 2.001. In order to find the function values at each of these points, we can go ahead and substitute the x values into the function, or you can use a table feature in your calculator. First, let's find the function value at 1.9. In order to find this function value, we need to substitute 1.9 in for x everywhere in the function. Now let's input this into the calculator. For the numerator, we get negative 0.48, and for the denominator, we get negative 0.1. And this simplifies to 4.8. So now we will put 4.8 on the table. Now let's do the same for 1.99. When you substitute 1.99 in for x everywhere in the function, we get 4.98. And now we do the same for 1.999 and we get 4.998. Now let's repeat the same procedure with the values to the right of 2. When we substitute 2.1, we get 5.2. When we substitute 2.01, we get 5.02. When we substitute 2.001, we get 5.002. Now let's interpret the values on the table. First, let's look at what's happening to the left of 2. So we have 4.8 and then 4.98 and 4.998. So what value are we getting close to? So notice that as our x values approach 2 from the left, we are approaching 5. And now let's see what's happening as we approach 2 from the right. We have 5.2, 5.02, 5.002. So as we are approaching 2 from the right, the function values are also approaching 5. So even though the function is not defined at 2, the function is getting closer to 5 as we approach from the left and from the right. Now let's look at a graph of the function. So if we look at x equals 2, you'll notice that there's a hole in the graph. So the function is not defined at 2, but remember that we're not really concerned at what happens at 2. We want to see what's happening to the left of 2 and to the right of 2. So as we approach 2 from the left, the function value is approaching 5. And as we approach 2 from the right, the function value is also approaching 5. So the values of f of x when x is very close to 2 are approaching 5.